Welcome to our video for practice 2. In this one, we're going to be reviewing how to run an independent t-test in SPSS. And then we're also going to practice calculating Cohen's d effect size and then graphing or creating a graphical representation of the difference between two means, which is usually best depicted with a multi-series bar graph. And we made these way back in our first activity, so it might be a little bit of a refresher for some of you. But as far as the data that we have in our practice 2 spreadsheet, this is the kind of research scenario of interest. So you are interested in finding if the average amount of sleep per night in hours differs between males and females. A random sample of 395 undergraduate students, there being like 194 males and 201 females, self-reported the average number of hours of sleep they got during a typical week during a school semester. So as far as our tasks in this practice set, we are going to assume the data are normally distributed for both males and females. That way we can just go ahead with our test. And then we're going to run an independent t-test in SPSS to find if there's a significant difference between the groups or not. From the information that we get in the t-test, we are then going to calculate the effect size of the difference between genders, and then we'll create our bar graph. So let's go over to our data. I've provided you guys with a legend for gender. So anytime you see a 0, that represents a male. Anytime you see a 1, that represents a female. And then their sleep time has also been noted in another column indicating time in hours. So I've also indicated what the sample sizes are. The sample is quite large. So usually when this happens, we're not as concerned with bigger differences between sample sizes. So in this case, this would be close enough. If some of you crazy critical thinkers in this class are like, oh, the samples aren't different, would that affect the results? In this case, not really, because our sample is really big. Okay. So given this information, this is how you should have your independent t-test data set up, where you have one column that's indicating the group or category that a person has been sorted into, and then the other column is going to be representing the variable that was measured. So this setup is important because when you put this in SPSS, remember that each row in SPSS says, oh, this is subject 1, subject 2, subject 3, right? And so everybody who is listed in SPSS should only have one measured value associated with them and one category so that we can identify which group they actually belong to. So from here, I'm just going to highlight and copy my data, and I'll paste it into a data set in SPSS. I then need to go to the variable view to adjust what my values mean for gender. So we can do this in the value section, where 0 is representing males and 1 is representing females. That way SPSS knows that these values are not numeric, and they won't be used in any statistical calculations, but rather they're just going to help group our people into the appropriate categories. We then need to change our measure to nominal for gender. Sleep time is going to be scale or ratio, that's our continuous variable. So once we have our data formatted such that it looks like this, we can then go into Analyze, Compare Means, and run our independent samples t-test. Our test variable is going to be our dependent variable sleep time. Our grouping variable is our independent variable gender. And then you'll notice we have two little question marks here. We need to define our groups. Group 1 is going to have a specified value of 0, so that's our males. Group 2 will have a specified value of 1, which is our females. So we can press continue. We don't necessarily need to have estimate effect sizes on here, but let's keep it checked to keep it interesting. And we can press OK, and that should give us an output. And I'm going to extend my window a little bit so we have more information on our screen at one time, because these tables can get a little bit lengthy. I'm going to take out the log and the notes as well as the active data set, because those are just going to crowd my output when I export it. This t-test I will identify with, let's do practice 2. And I can also note that in the title in my output, so that way it gets, that way it gets transferred into the output that's exported. So again, I like to do this because it's easier to find things when you go through your output, but you don't have to do this if you don't want to. It does make it easier for me also when I'm grading though, so I don't know. I think it's a win-win, but anyways. Okay, so at the top of our table, or on top of our output, we have our group statistics showing us our male and female categories, and then the sample size associated with each of those groups, the mean, and the standard deviation associated with each of those groups. We will end up using this information, these 3 bits here, to calculate the effect size in our Cohen's D example. And it's kind of nice because we have our effect sizes down here, so we can kind of see how they compare to what we calculate. For our independent samples t-test, you'll notice we have 2 sections of our table, which remember this one is a little bit different than what is in your lecture table, because the table was too long in the Laird Statistics website. So this is what it should look like on your screen. You can see we have Levene's test for equality of variances, so this is our homogeneity of variance test. And then there's a line that splits the table in 2, and then we get our t-test for equality of means. So the areas of the table that you want to draw your attention to is the p-value for Levene's test, as well as the p-values for the t-test. It won't always be the case where both of the p-values for the t-test are the same, and that's because of if you have equal variances or not. So remember, we have to check our Levene's test assumption first by looking at the p-value under Levene's test in the table. So we get a p-value of 0.506, which is greater than 0.05. Recall that the null hypothesis for Levene's test is that we have equal variances between groups, or each sample has an equal variance. So if p is greater than 0.05, we accept the null hypothesis, and we can argue that we have assumed equal variances. So once you evaluate this p-value, that will let you know which row you're supposed to read for the t-test. Right? So since we've got equal variances assumed, we're going to read this top row here, and that will tell us what our p-value is for our t-test. The null hypothesis for the t-test is going to argue that there's no significant difference between males and females for the amount of time they spend sleeping per day. Right, so in this case, we have a p-value that has, that is 0.206. This is greater than 0.05. So when we have a p-value greater than 0.05, we can accept our null hypothesis for the main effect of our test. So in this case, we would interpret that p-value as that there are no significant differences between males and females for the amount of time they spend sleeping every week. Right? or amount of time they spend sleeping per day, excuse me. Okay. So that in general is how we read the independent samples test area. And now we're going to calculate our effect size. So I'm just going to minimize this, my SPSS screens really quick. If I toggle over to your instruction sheet and scroll down, I've included the, equations, that's what they are, to calculate Cohen's D effect size. So when we are looking at an independent t-test, we want the absolute value of the mean difference divided by the pooled standard deviation, which is identified as the square root of the standard deviation squared of sample 1 times the sample size of sample 1 minus 1, plus the squared standard deviation of sample 2 times the sample size of sample 2 minus 1, all divided by our degrees of freedom, which is our total sample size minus 2. So using this, I'm going to pop over to my Excel spreadsheet, and I'm just going to insert the variables that we have to calculate our effect size. So I have, let's see, let's say mean 1 or x1. We have mean 2. We'll have a, standard deviation 1, standard deviation 2. And then we'll also have a sample size 1 and a sample size 2. So this should be all the information that we need to be able to calculate our mean difference and our pooled standard deviation. And then we can use those two values to figure out what Cohen's D effect size is. Okay, so we already know that our sample size for our males was 194 and our sample size for females was 201. That came from the information I gave you guys already. The means and standard deviations are going to come from your SPSS output. So if we go into our group statistics here, if you double click in this table, you can pull out these values and then we can paste them into our, whoops, guess that didn't like me. Let's copy, right click copy. If all else fails, just try something different. Okay. In SPSS, it listed our means first, and then it listed our standard deviation, so I'm just going to cut and paste these underneath. Okay. Our mean difference is going to be the absolute value of x1 minus x2. My pooled standard deviation is going to be equal to the square root. And this is where we have to get our parentheses sorted out. So the square root function itself needs a set of parentheses. Our numerator is going to be in a set of parentheses. And then each of our sample characteristics are going to be in their own set of parentheses. So we'll have 2 more sets of parentheses added in there with a plus sign in the middle. So far we're at 3 parentheses to kind of start our square root function, but I just wanted to tell you how we get there. Okay, so from here, in this first set of parentheses, we're looking at the standard deviation squared. So for our first sample, we can just click on this cell reference and put a caret with a 2. That'll be squared. And this will be multiplied by n minus 1 the sample size of our sample 1 minus 1. Okay. Then we can do our second bout of, or for our second sample, where we're doing standard deviation squared times another set of parentheses, and now we've got our sample size of sample 2 minus 1. Okay. Our numerator is surrounded by the red parentheses, just to kind of call back. And we're dividing this by another set of parentheses. Okay. We're doing n1 plus n2 minus 2. That's our degrees of freedom. Okay. So then we can press enter, and we should get the pooled standard deviation for our sample. From there, we can say the mean difference divided by our pooled standard deviation is equal to our effect size, which if we pull this down, we get 0.128. So let's see if we calculated this correctly. We go into our independent samples effect sizes, and we can see the point estimate. This is the actual effect size that's been calculated. So under Cohen's D, we can see we have an effect size of 0.128. Yay, we did it right! Okay, so this is basically going to tell us, if you recall from the scale that I gave you guys in the lecture, values of 0.2 or lower are considered small differences. Anything between 0.2 and 0.8 relatively, so mostly something around the 0.5 area is considered a medium or moderate difference, and then anything larger than 0.8 is considered a large difference. So in this case, when we look at the mean differences here, even though they're not like this, well, I guess the nice thing about effect size is that it tells you how large the effect needs to be for significance. So in this case, our difference between our means was not significant, and that indicates that it was a small effect size. Therefore, a small difference is not likely to read as significant. So that's kind of how we can interpret what this effect size means. It's a very small difference between the means of our groups. From here, we can now create our multi-series bar graph. So in order to do this, it's going to be helpful for us to rearrange our data a little bit, so that way we have our values nicely represented so that they pop into our graph the way that we would like them to. So I'm going to make a table that has my average and standard deviation noted in the column, and then I'll have males and females listed here. My average for males was this value here, so I'll just copy paste. Females, make sure that you're not copying the wrong value in the wrong spot. But from here, what we can do is highlight our average values, go to Insert, and then Insert Bar Graph. That should automatically have our bars or our groups marked with the appropriate label. My chart title might be something related to the description that I gave you guys. So mean sleep time in college students maybe, or mean sleep time per day in college students. In my chart design tab, I can add a primary vertical and a primary horizontal axis title. So the vertical title will represent sleep time in hours, and my X or horizontal axis is going to represent gender. I then can also use the Add Chart Element tool to add error bars. And we'll do more error bar options, which should pull up my formatting toolbar on the side. And in this, I'm going to keep the direction as both, so it's going to be both plus and minus the standard deviation from the mean. And then we need to do custom and then specify value with our positive error representing the calculated standard deviations, and the negative error also representing the calculated standard deviations. So then I can press OK. My errors change. And then I think that this is a fairly acceptable range of data for a vertical axis label, so we'll just keep that as is. But your graph should look something kind of like